Hello everyone, this video is about unsaturated, saturated, and supersaturated solutions. So there's a big difference between the three scenarios, and I'm going to explain it over here. For an unsaturated solution, that means it's a solution that there's still room for ions to dissolve in water, meaning you're adding a solid, let's say, to water, and there's still room for it to dissolve. You haven't reached a maximum amount yet. So in that case, when you show an unsaturated solution, you always show it with a one-way equation. So let's say we have an unsaturated solution of NaCl. So what happens to NaCl is once you dissolve it in water, it 100% ionizes into its own ions, which is Na plus and Cl minus. Again, keep in mind that ions are always in the aqueous form, meaning they're dissolved in water. So that's what happens when an ionic compound is dissolved in water. So the ions are dissociated, they're separated, and that way, let's say if you know the concentration of NaCl, then you can find the concentration of its ions right away based on their stoichiometry, based on their balanced equation, which is a 1-to-1 ratio. Or let's say we have an unsaturated solution of CaBr2, for example. So when you dissolve CaBr2 in water, what happens is that it dissociates into Ca2 plus ion and 2 times Br minus ion. So you get 2 Br minus for every calcium 2 plus. So again, here, if the concentration of Br2 is 0.5 molar, then you know calcium would be 0.5 molar, but Br would be double that because of the 2-to-1 ratio between Br minus and CaBr2. So it would be 1 molar. So this is the case of unsaturated solution. Now, for a saturated solution, that means it's a solution that the maximum amount of solid has been dissolved in it, meaning there's no more room for adding or dissolving any more solid in this solution. So if you continue adding more solid to a saturated solution, what happens is that the solid will remain in the bottom of the container and it's not going to be dissolved. So showing a saturated solution is basically using an equilibrium sign. So let's say we have a saturated solution of AgCl. So the way you show it is that you put the solid on the left, then you put an equilibrium sign and it changes into Ag positive and Cl minus ions. So in this case, if you want to find the concentration of Ag plus and Cl minus in the solution, you have to use KSP value, which stands for solubility product constant, which is at the same time the K equilibrium for a saturated solution. So you have to do calculations for that. I have another video that will tag over here, and I'll show you if you want to learn about how to find the concentration of these ions in a saturated solution. I can show you how that works. Or let's say we have another saturated solution of, let's say, PbBr2. So in this case, again, the solid will be on the left, equilibrium sign, the ions on the right. And as I mentioned before, if you want to find the concentration of these ions, or if you want to find the maximum amount of PbBr2 that can dissolve in a saturated solution, you can always use the KSP value for that. And then the third case is the supersaturated solution. So a supersaturated solution is the solution that it's past the saturation point, meaning you already added more than the amount that you were allowed to of the solid into the water. So it's not going to dissolve anymore. So that's when the precipitate starts forming. So in the supersaturated solution, the way we show the equation is that we always show the ions on the left, and then they go towards the precipitate. So for example, let's say I have a supersaturated solution of AgCl. So that means then the Ag plus ions plus the Cl minus ions, they react together and they form us the precipitate again in a one-way equation. Or let's say if I have it for PbI2. So if you want to show it for PbI2, what you have to do is to show the ions further. So it's Pb2 plus ion reacting with 2 I minus ions, and together they will, in a one-way equation, become PbI2 solid. So these are all three cases of solutions that we can have. So unsaturated, saturated, and supersaturated. And it's very important to understand how to find a concentration of ions in each case. Or for the case of supersaturated solution, you can always find the mass of the, for example, precipitate form in that case. All right, so that was it for this video. I hope you liked it. If you did, I believe you're also going to like my next video, which is about saturated solutions and the KSP calculations. Hope to see you in the next video.